Hello everyone, my name is Nicola Paolucci. I'm a developer advocate at Atlassian, and today I have for you advanced Git techniques, subtrees, grafting, and other fun stuff. These are slightly more advanced topics than I generally cover, and I think you'll find these very useful, and my aim is to enhance your experience of daily version control activities. And this is how I imagine you will become at the end of this session. I might come and check on you in a few weeks, and then you'll tell me if these techniques have helped you or not. Anyway, this is how I feel when I use these techniques, so I'll show you. And this short video will loop for a bit, so we can stay here and look at it for a while, or we could keep going. So these were the three topics that I thought might be interesting to share. That for different contexts and different uses. The first one is related to a pain that all of us software developers have, and that is how do you handle project dependencies with Git. There's a few ways to do it, and we'll talk about different options. For these sessions, I would like to dig a little bit deeper into one specific Git commands and one specific Git facility called subtrees. And I'll tell you why that works the way it works, when it can be useful, when actually you shouldn't use it, and alternatives. Then I thought about a technique which a lot of experienced Git users, and especially developers really into version control techniques, use daily, but not many average Git users are familiar with, because it's a bit scary. It has weird prompts. So I'd like to show you how to do interactive staging, interactive commits, and dispel the myth that that is too complicated. Also tell you why you would want to do that. That probably will help. And then third is also a slightly more advanced and esoteric topic related to if you're just now migrating to Git, and maybe you have legacy repositories that you want to bring along, and you want to preserve and save the histories of your other systems and move them to Git, there's a cool technique that you can do to actually attach unrelated histories in Git by using a command called git replace. And I want to show you a little bit how that works. So that's the plan that I have for you today. There's going to be time. If there's no time at the end for questions, you're free to find me later. I'll be here the whole afternoon. So the first topic is git subtree. It is actually not a new command. It has been in the Git distribution since 1.7. We are up at 2.6, almost 2.7 right now. So it's a tool that's been there for a while. But in my experience, it's not really widely used or widely known. So what the Git subtree allows you to do, it allows you to inject another Git repository external to your current project into a folder of your current project. And also it allows you to do the reverse. It allows you to extract a sort of folder in your repository and create a completely separate repository from it, preserving all the history of the changes done to that specific folder. So that's a very high-level definition of what Git subtree does. Now, there's a few other facilities in Git and also outside Git that allows you to manage dependencies. So I see a question in your mind, like, why would I want to use this specific one? So there's a few reasons why Git subtree is a bit different than the other Git commands that allow you to manage dependencies. The first one is that, it wasn't showing. The first is that it requires, for the whole team, it doesn't require them to learn any new command. So the person that handles importing that dependency, that library, that external repository into your project needs to learn this new command, and I'll teach you how it works. But the rest of the team doesn't need to learn any new command. And the reason is because Git subtree stores information about the dependencies that have been pulled inside regular commits. So the rest of the team can keep working. You can see in commits which versions have been imported into which folder. And it's very transparent to the rest of the team. So that's one of the positive reasons why Git subtree could be useful to you. And also because integration points where you pull dependencies are just regular commits, it makes it easy to see when things have changed, when a library has been updated, when the dependencies have been updated. So those are three reasons why Git subtree
could be interesting to use in your projects. Let me show you how it works. It's not too complicated, just some command line flags you have to learn, as you always do with Git. So it all starts with the git subtree command, and then you specify a sub-command about what you want to do. And when you want to pull a certain repository, external repository, into your current parent repository, you use the add flag. Then you specify the folder where you want to inject that external project. You specify the repository, the external repository that you want to import, and which branch of that repository you want to import. So generally, the default way is if you just want to pick the latest commit of the repository, you can specify master, but it's a more clean solution to actually pull from a specific release branch or release tag so that you have an easy way to know exactly which version you've been injecting into your source code. The last flag, the -- squash, what it does, it takes the entire history, all the commits of that project you're importing, and squashes all of those into a single commit, which I recommend you do for, generally is the cleanest way. So that way you will have a single commit in your local history that will represent, importing a project into your parent project. The way Git subtree achieves all this, well, it does store some metadata into the commits it creates. So it creates a commit with a few flags, few labels. So Git subtree directory, Git subtree split, where it stores the identifier of the commit of the external repository that it is importing. And after that, to make sure it is explicit that you're importing something from somewhere else, it actually creates also a merge commit so that you always have a traceability that's not a simple commit, but it's something that comes from somewhere else. If after a while the developer that's managing that specific dependency wants to update the library or the external repository, you can do it with the git subtree pull command. That works like that. So you just type git subtree pull. You specify the prefix where you have injected that specific library. Obviously, the repository where that external library or external dependency lives. And again, you specify which branch or which tagged version you want to update to. So in this case, after a while, you have imported version 1.1. Maybe you want to actually pull and update that library to version 1.5. So under the hood, as I said, what Git subtree does, it squashes all those commits, create a single commit for all that all those code changes, and records where you have injected that piece of code and a unique identifier. Now, because in the commit you have this unique identifier and not actually the version or the tagged version that you have imported, sometimes you might lose track of what was that identifier related to? How did it match to the tagged version I wanted? So there's a command. It's a slightly lower level Git command. It's a plumbing command that is called ls-remote that allows you to list basically all symbolic names, so SHA-1s or commit IDs to their symbolic names. So if you want to know exactly what you have just done, you can grep doing git ls-remote, grep for the identifier that you find in the commit. And this is like a way to know exactly which version was pulled in that commit. Now, this seems overly complicated. I'll show you a few shortcuts that will make your life a little bit easier just in a second. This is just to show you. So you use git ls-remote, the remote repository, and then you grep for unique identifier that you saw in the commit, if there's ever a confusion about what happened with those libraries. Now, tapping git subtree add and all those prefix and then the master and then squash can get lengthy. So my recommendation, if you want to use this facility, is to create a couple of aliases that will make your life easier. You don't have to take notes on this. I created a very short URL for you where you'll find these aliases and others that you can check out, bit.do/git-alias. And if you install this into your .git config file, you'll be able to then have a command that works like this. You git subtree add, SBA, repository, and the folder where you want to inject the dependency. Now, this assumes you're going to pull the master. So if you want to change it, you need to change the alias to import and pull some other tag. Now, this is all nice and very neat and very clean tool. Is it like a solution for all your dependency problems? The answer is no. There's a few reasons why you might not want to use this facility. Let me give a few examples. If you were talking about, like I've talked with some of you in the past couple of days, if you have a project with a lot of dependencies and you're constantly updating them and it's in the dozens, Git subtree probably is not for you because you're going to be spending a lot of time updating them manually, which is not optimal. At the same time, even if you have a few dependencies, but you have to constantly pull the new versions up, that also might not make this process really user-friendly. And at the same time, if the entire team needs to do this operation, and not only a few persons that are more familiar with this command, that will make the first point I made. Nobody has to learn Git subtree apart from the person maintaining the dependency. But if more people have to learn it, then you lose that benefit as well. Now, I know what you're thinking, because I have spoken about Git project and project dependencies before. And I have even written about it. So, and my recommendation has always been, whenever you have a complex dependency problem and you want to use Git to track project dependencies, do not use Git. Use a dependency management tool. So there's actually a dependency management tool for each technology stack, language stack, whether you use Java, Ruby, Python. There's always a package manager, dependency manager that will help you manage your dependencies. Git subtree still has its own niche and usefulness. But for complex, bigger projects, you should rely on Maven, pip, Ruby gems, npm, whatever is needed for your technology stack. Git subtree can be used for another incredibly useful thing. You will probably have run into this need before, and you have a big project. And after a while, you recognize that there's a small component of of that project that should be actually separated in a common component. And you want to track that sub-project in its own repository. And then historically, to do this, you would need to use a complicated git filter branch command, and it's a bit painful. So actually, Git subtree can allow you to do this split, extract a project outside of a repository and in a completely new repository. So let me show you how that works. Yeah, I like this picture, by the way. It's fun. So how does it work? It's Git subtree split. This is the command. Then you specify which subfolder of your project you want to extract into a separate repository. And for the time being, what Git split will do will actually store the contents of the history of that subfolder into a branch. So you specify into which branch you want to copy the history of only that branch, or only that file, with all the changes done to those files. And once you've done it, you have a branch that only contains that folder and all commits related to those files changed in that folder. So it's a shortcut to a really advanced Git filter branch command. Once you have this, the path to extract it into a separate repository is relatively simple. First, you remove that branch from your current repository because you will move it somewhere else. Second, you initialize a completely new repository. And in that new initialized repository, you pull that new branch that you've just created. So you pull specifically that path where you have created the new repository, and you specify that you want to import. Sorry, you pull from the parent repository, and you specify the branch that you've just created. And then it's just a matter of creating a remote somewhere on Bitbucket or wherever you host your code, and push it there. So compared to some of the shenanigans you have to do with other commands, this Git subtree split allows you very easily to extract any dependencies out in its own repository, which is fantastic. I've used it several times. You should give it a go. Okay, this closes my speech on Git subtree. Hope you found it interesting, and you'll let me know later. The second topic is about interactive commits, and this, I think, all of you should give it a go and should explore it and try it out without fear of doing damage or destroying things. And so the first time that you'll try it, probably this is what's going to happen. I'll just give you a warning. Also, this is a loop, so this will go. So why would you want to split the so let me first frame the problem. We developers, like, we have a feature to implement, and as we're working on that feature, and at one point we realize, hey, actually there's a bug here. This is a different thing, but I am in the same file, exactly this file. Let me fix this bug too. Oh, and by the way, this method is too long. Let me split it up in a couple. And instead of working on that feature, now you have 3 separate things, all modified in the same file. And if you were like a good developer that likes to give to peers nice isolated atomic commits to review, you would just split those 3 into 3 different commits, right? Only that now it's a bit of a painful process. So this is why interactive commits come handy. Where you can do interactively decide line by line what is going to go into the next commit. So just to summarize it, I put these points up on there for you. It's always nice if your commits do record one action per commit. So 1 feature, 1 extra feature, 1 bug fix, 1 refactoring. It's never nice if you add too much stuff to a single commit, and then it gets much harder to review. And so by knowing this technique, you can just go into full coding mode, crazy coding mode, and you can add as many features, bug fixes you like to as many files you're editing, and then decide at the commit phase what to actually commit and what leave out. So it gives you a fine-grained control of what's going to go in your commits, and I would like to show you how that works with an example. Because without having you to know any specific language, I thought I'd do an example with a text file. So this is a simple markdown file with a title, subtitle, and conclusions. And I was so excited that instead of doing a commit for the title, a commit for the subtitle, and a commit for the conclusion, I've actually added 3 lines to 3 different sections of this text file. And now you should think about how it would look if you're working on a feature plus a bug fix and you'd like to split them up. Now, the way to do it with an interactive commit, you just type this dreaded command, which for some of us has been scary for a long time. It was for me as well. You type git commit -- interactive, press enter, and you're greeted with this very long prompt with a lot of choice. Now I want to dispel exactly what you're seeing. What you see is a list of the files that have modifications, that have content changes, and then a prompt with commands that you can actually do interactively, step by step. And we'll talk about these commands in a second. They're not too complicated. For example, taken one by one, they're fairly self-explanatory. For example, status. It just tells you the status of the files and which content you have already added to the staging area or to the next commit, or you haven't. So you can just do, it's like a git status. Update allows you to add an entire file to the next commit. So if you've done changes to a certain file and you know that all those changes should go into the next commit, you can just type update and then the file number or the initials, a pattern that Git will recognize for that file name, and you can add it to the next commit very easily. Revert allows you to undo the operations that you've been doing on that specific file during your interactive session. And there's a few more. Diff, obviously, is like typing git diff. Add untracked is the same as git add when you're adding a file that is not into your repository yet. And the most interesting one, and the one that I want to show you and demo to you, is patch. So patch is the command that allows you to decide in a single file what to do line by line. Do I add this line to the next commit, or do I not? The problem is that when you type p, or patch, and then the file that you want to work on, you get this. So you type p, then you say, OK, I want I want to decide interactively on the README file, so I press 1, then you press Enter. And Git asks you this. When you get there, you see those 3 modified lines, and then it asks, you want to stage this hunk? And I know, so my face when I first was trying this was like this Git. So it goes like, what? Yes, no, and then there's like 20 different options. And so just to dispel the confusion, I've realized, I've learned, not really native English speaker, that a hunk is just a piece of text, continuous lines in a text file that contain changes. And the size of this hunk is configurable. So, but let's just do this interactively together so that we work through it together, and hopefully you will see that it's not too complicated. So, see if this starts. Wait. I don't see the... OK, there you go. So I start my interactive sessions by typing git commit interactive. So Git shows me, hey, actually, you have changes to the README file. What do you want to do? And I say, look, I'd like to patch interactively and decide what to commit for file number 1. OK, good. Then I press Enter to confirm that I want to work on that specific file. And now Git tells me the famous question, do you want to stage this hunk? So Git is considering that, asking me, so those 3 lines, do you want to add them to the next commit or not? And this is too much. This is actually all my commit. I want to be a bit more fine-grained. I want to actually split this hunk. I want to make the chunk that Git is analyzing smaller. So there's a command for that. It's the split command. So I type S for short. And so the Git will say, OK. So this chunk was too big. Let me go line by line. OK, so the first line, do you want to commit this line? We answer yes. Yeah, it's OK. I want to create a commit where I change only the title. So I type yes. And then it asks me about the second line. Do you want to put this into the staging area for the next commit? No, this I don't want. So I just say no. And the third line as well, I can say no, I don't want to commit this one. So this is a way for me to explain you how you could commit only a feature and leave the bug fix out. After I'm done, I can just quit this session, typing Q, and you're dropped into a commit dialog, like your editor opens. I can say, OK, I just added a section to the title, and this commit will only contain that change that I staged. So if I do a git diff, you see, the second and my last line are still there, while the first has been committed. So if I do git log -- one line, just for short, and last 3 commits, you see now I have an extra commit that contains change to a single line. All right. So as you can see, just to recap, because maybe it was a bit too fast, whenever the hunk you're working on is too big, you can split it by typing split. And then you decide, you tell that if you want to add that specific line to the next commit or not. And after that, you will have a special commit that is only on part of the modifications you did to that file. So this technique, obviously, I can only give you a brief sense of what you can do with interactive commit. But it's incredibly powerful and allows you to really tailor on the fly what you're going to be putting into your commits. So don't be afraid to explore it. And if you ever get scared about that specific question, you can always type question mark, and you'll get a list of all the commands. And they're not too complicated. The stage or not stage means, do you want to add this, schedule it to be added to the next commit or not? Do you want to quit? Do you want to skip this one and decide it later? So once you try it a few times, these options become relatively simple. Hopefully, with this brief introduction, you will be more comfortable to try it out. OK, that was interactive commit. Now, the last part is about collating history of unrelated repositories, or from legacy repositories to newer Git repositories. And I was thinking about an image that would represent touching stuff together. So this is somebody who used magnets to crush a $10,000 gold Apple Watch. I found things on the internet that are fun. So why would you want to attach histories of Git repositories. Let me give you an example of why would you want to do that. So imagine that you want to move your team to Git, but you have a legacy Subversion repository that's been there for years, and the migration is going to take a while. But your team really wants to move to Git right away. So one way to do that is to create a shallow clone of a Subversion repository, move that last snapshot from Subversion and import it to Git, and everybody starts working on Git right away. And you can do the migration at a later stage. And then at a later stage, you can attach your newly migrated legacy repository to the new repository where everybody has been working on. This is one of the uses of this technique that I want to show you. The other use for this technique is when you have two repositories which are separate, but actually they should be only one, and you want to preserve the history of both. So that's also one way, one reason why you might want to attach the histories of two unrelated repositories. And also this technique can help with really complicated merges between different version control systems, but I'm not going to go into that topic today. It would take a bit too long. There's actually one relevant example of this technique. The Git was created to manage the Linux kernel project, obviously, as many of you might already know. But if you clone the current Linux kernel repository, you're not cloning the entire history of the Linux kernel. Actually, it's 3 different repositories that you need to assemble yourself using this technique. So originally, the Linux kernel was reconnected using a technique that only worked locally for each of your clones locally, and you couldn't share those. You had to share those in a text file and send it to people. And then nowadays, there's a command that allows you to actually preserve and store replacing commits one by one, and it's called git replace. So git replace, what it does is it's capable to replace any object in a chain of commits with any other object, and you can also store those in your refs so that you can share this information. Now, if you have this facility, how would you accomplish one of the tasks I mentioned before? Let me show you. So imagine that your team was really eager to start using Git, and so you just took a snapshot, the latest commit from Subversion, you imported it into Git, and now your whole team is working in a shallow, in this case it's a branch, but it can be a repository, which is a shallow clone, originally a shallow clone of your Subversion repository, while you have a legacy history of Subversion that at one point you've managed with a lengthy and planned operation to migrate to Git. What git replace allows you to do, provided that you have tagged the first commit of your shallow repository and the last commit of your legacy repository, is to type git replace first with last. And this is the magic that happens, is this. So git replaces one commit with the next and pretends that the histories were never separated and everything is together. It's very simple. It's exactly as simple as it gets. The only thing I wanted to show you is if you want to do this operation, it's one of those simple tips. How do you find the first commit in a branch? You use git log. Git log is your Swiss Army knife to search for any commit in Git. And in this case, the flag that you want to use is, I would like to find a commit that has no parents. That's the first commit in a branch, max parents equals 0. And obviously, you want to tag that. Just for the sake of this example, you note down that ID and you tag it as my first commit. And then if you want to know exactly where what the latest commit of a branch is, you can use many techniques. This is one. You can use ref parse -- verify, and you'll get the unique identifier of the last commit of a branch. You tag it last. And once you have those 2 tags, the command is git replace the first commit with the last. And I just replayed the animation for you. It's beautiful. It took me a long time to do this. So. No, I'm kidding. But so the beauty of the git replace command is that these swaps are tracked into refs. So if you go and check into the .git folder, there's actually a section called replace that will have all those identifiers swapped, tracked. And so this allows you to share these swaps with your colleagues so that they don't go lost. Now, it's always a bit clunky if people have to remember to pull those replace commits. So if you've done this operation, at one point you might want to pause all developers and run one pass of filter branch that will basically make this connection permanent and transparent. And so from then on, your repository will be indistinguishable, and there won't be two parts anymore.
I have a final slide, which it's meant to be aspirational for you. And now with these cool techniques, I encourage you to experiment, explore them, and let me know if you found this material useful. Again, thank you for watching. Now you know a little bit more about these advanced techniques. I hope you enjoyed them and you'll find them useful and incorporate into your daily version control routines. If you enjoyed this presentation, check out another one of my recent blog posts by the catchy title 14 Tips and Tools to Resolve Conflicts with Git. I put the link in the description below. And don't forget to click the subscribe button to get the latest videos. We publish constantly new material, so I encourage you to check it out. If you have any questions, make sure to follow up with us on our QA video and visit answers.atlassian.com. As always, thank you for watching, and I'll see you next time.